Welcome to another episode of Nostalgic Math Chats. We're looking at IEB May 2023, Paper 1, Question 12b. Determine the value of P if the sum, and this is an, what do we call it? A sum to infinity of 2 to the negative n plus the sum from 1 to p of 2n plus 1 is equal to 484. Okay, so the first thing that stands out for me is this first term on the left hand side, this sum to infinity, because a sum to infinity is just a number. So if we can simplify that term to just a number, then all we're left with is, I think, probably an arithmetic series. So let's see if we can simplify that first term. So sigma n equal to 1 up until infinity of 2 to the minus n. So if we expand that sum a bit, that's just going to be 2 to the minus 1 plus 2 to the minus 2 plus 2 to the minus 3 plus 2 to the minus 4, and so it goes. And to make things a bit clearer, this is just the same as a half. 2 to the minus 2 is 1 over 2 squared, which is 1 over 4. This is 1 over 2 cubed, which is 1 over 8. And this is 1 over 16. Right? So this guy here is a geometric series, right? Where A is equal to a half and R is equal to a half, right? Each term is half the previous one. So we can work out sigma, not E, sigma of n equal 1 until infinity of this guy by putting this into the formula for the sum to infinity, right? For a geometric series, which is the sum to infinity is equal to A divided by 1 minus R. So A, we said, is a half, and we have 1 minus a half, so that ends up being 1. Nice. So that term just simplifies to 1. Very, very cool. So I'm going to move this now. Can't I add a page? I want a page. They will not have me have a page. How unfortunate. Maybe I need premium. The premium version of this app. Right, so we now know that sum, that sum is just 1, right? So we can rewrite this as 1 plus the sum from n equal to 1 up until p of this guy is equal to 484, which is just the sum from n equal to 1 up until p of 2n plus 1 is equal to 483, right? Just subtract 1 from both sides. Okay, so let's see what kind of sequence this generates. Right, so if we expand the sum, then we have 2 times 1 plus 1. Okay, I'm just going to kind of keep these together so that we can see what the term is, the 2n plus 1 term. This is 2 times 2 plus 1 and 2 times 3 plus 1. So we can pretty much see this is an arithmetic series, and it's going to stop at 2 times p plus 1. Okay, I'm just going to shrink this quickly. Right, is equal to 483. Right, so let's just simplify each of these. So this is 3 plus 5 plus 7, and the last term is 2p plus 1 is equal to 483. Okay, so this is an arithmetic series where a is equal to 3. The difference between each term is 2, and the number of terms in the sequence, remember we started from n equal to 1 up until p, so 1, 2, 3, 4, 5, 6 up until p, so that means there are p terms. Okay, we're using n confusingly here because we're using it here and there, but just for the sake of consistency with the arithmetic series or sequence formula, right? This n is just the number of terms. In the series. Okay. Right. So we can then use the arithmetic series formula to figure out, to figure out what p is, hey. So we have a choice between n over 2 times 2a plus n minus 1 times d, which is the same as n over 2 times the first term and the last term in the series, right? That gives us the sum of the first n terms. So obviously this one is more appealing, just looks simpler. So let's use that. Okay, so the sum of the first p terms is going to be n, which is p, over 2 times the first term plus the last term, which is 2p plus 1. And we've been told that that is equal to 483. And to make life, let's not preempt. So p over 2, that simplifies to 2p plus 4, which is quite nice, right? So what I was tempted to do was to multiply both sides of the equation with 2 so that I could get rid of that division. But thankfully, both terms inside the bracket are even, so they are going to get rid of the division for us. Right, so I'm going to divide the 2 in there and in there. So we're just going to be left with p times p plus 2 is equal to 483. Let me move this guy onto the new page now that I have a new page and I don't have to get the premium package. Wait. There we go. Right. So we are now getting a quadratic equation, and of course with our quadratic equation, well, depending how you want to solve it, I feel like with this being such a big number, I don't really intuitively have factors that I can try out to factorize the expression. Completing the square, I don't do unless I'm specifically asked to, so that leaves us with the quadratic formula. So we have p squared plus 2p minus 483 is equal to 0. So that means P is equal to minus B plus or minus B squared minus 4 times A times C, okay, divided by 2 times A. Let's see what that gives us. Okay, first let's shrink stuff. Okay, Mr. Calcs or Miss Calcs or non-gendered. Probably shouldn't be gendering the calculator really. So let's start with the minus. So that gives us 2 minus 4 times 1 times negative 4, 8, 3. And here we have 2 times 1. So P is equal to negative 23, or P is equal to, you can just change this to a plus, and that gives us 21. Alright, so it's one of those two. However, this calculator will always thwart me. Hey, what do you want from me, calculator? I'm so sorry that you have to keep experiencing this. One day I'll get it right. Okay. But remember that P is the number of terms in the series, right? So P has to be a number that's bigger than 0. It could be 0, I guess. But yes, it can't be a negative number. It definitely can't be a negative number. So, but, well, and the fact that the sum of the first P terms is not 0 means that, no, that's not a fact. Okay, the fact that the sum is some number bigger than 0 definitely suggests that at least one term is in the series, right? That is a fact. Right, so we know that P must be greater than 0. Therefore, P is equal to 21. That's our final answer, right? So if we take the sum to infinity of this expression, that's always going to be 1, right? That's fixed. That doesn't depend at all on P. And we add it to the sum of this expression, it should give us 484. I don't recommend sitting and, working out 2 times 1 plus 1, 2 times 2 plus 2 plus 1, 2 times 3 plus 1, 2 times 4 plus 1, up until 2 times, what was our P? Our P was 21, right? So you could technically work out those 21 terms and then add them together and see if you do get 484 when you add it with the one that we got over here. But I do not recommend that. I don't know how else I would sanity check this though. I don't know. If you have an idea, please comment down below. Thank you.